Oh my goodness, it's your lucky day because you get to solve equations with variables on each side. You thought solving two-step equations was fun? Ha! You are in for a treat. Here we go. Now, you might be wondering, what does it look like to have variables on both sides? Well, here is an example of it. You see there's a d on the left side of the equal sign and a d on the right side of the equal sign. Now, here's another example of what it's going to look like. Here are two more examples of what it's going to look like. You see over here that it looks a little different because it has numbers on both sides instead of just numbers on the one side. We call those constants, the ones with the terms without the variable. Anyway, we have these terms with the variable, we have the terms without the variable, term with, term without, and we're going to have to manipulate all those to get x all by itself so we can figure out what x equals. All right, you guys are seriously in for a treat. Now, we are going to jump over, before we get started on these examples, we're going to try to jump over to balance here. Balance, and we're going to try and kind of work through this so you kind of understand what's going on when variables on both sides. Balance works just like you would think. If you put something on one side, it's going to make it heavier. So how do I balance it out again? I could either take that piece off that I just put on, or I could add something to the other side. Ready for it? Wait for it, wait for it. Ooh, yay, it's balanced again. All right, I can even add a bag to that side and a bag to this side, and it balances out. All right, so reset it, and we're back to what we started with. Here are some things you need to know. The bags, we don't know what's in them. That's our goal, to figure out what's in them. One thing I do know is that each bag has the same amount in it. All right, if there's 2 in the first bag, then there's going to be 2 in all the bags. All right, so we just have to figure out what that magic number is. What is in each of those bags? So how can we do it? Maybe you can just look at it and figure it out. All right, but what we want to do is we want to relate this to our algebraic equations so it can help us understand the rules that we can use to solve those algebraic equations. Well, in algebraic equations, we want there to just be one variable on one side, all alone with nothing else going on. So in this case, we want to have a bag, a single bag on one single side and only blocks on the other side. All right, how are we going to manage that? How are we going to manage that? Well, I'm going to suggest this. We're going to take the bag off of the side, off the right side. Just take it off. Goodbye. Now there's no bag. Now there's no variable or no bag on that side. That helps us, but it's unbalanced. So what do we have to do? What do I have to do? Take a bag off of the other side. There we go. Now we've eliminated the bags on the right side and we only have a bag on the left. So that is our goal, to get the variable just on one side of the equation. All right, and now we have to get the second part of the goal. We have to eliminate all the blocks near the variable. We got to isolate the variable. We're going to figure out what just one bag equals. All right, so what we're going to do is we're going to start taking these blocks away. I'm going to take away 1, 2, 3, 4, 5, 6, 7. I'm subtracting 7 blocks. So what do I have to do to the other side? Subtract 7 blocks. 2, 3, 4, 5, 6, 7. Aha! Balanced, and now I know that one bag has 3 blocks. Now I'm going to reset this. I'm going to draw a little bit, and I'm going to show you algebraically what that looks like. So we originally started out with 2x, 2 bags filled with some number, 2 bags filled with some number, plus we had 7 blocks next to it. Now, on the right side of that balance, we had 1 bag and 10 blocks. And what did we do first? We just got rid of that 1 bag. We subtracted it. We took it away. Goodbye. But I have to do it to the other side to keep it balanced. Now, I'm left with 10 blocks on that side. I have now 1 bag and 7 blocks. And what did we do next? We started taking away blocks. We took away 7. And we took away 7 over here. Then we have 1 bag equals, or is balanced out with 3 blocks. So x equals 3. All right, so hopefully this helps us a little bit to visualize what's actually going on as we solve these equations. let's try another example, all right, and see if you can work through it and understand what we're going to be doing with those equations. First step, get the variable or the bags off of one side. So there's only a variable or bags on just a single side of this equation. So what are we going to do? Take away those bags, subtract the bags. So we got to do the same thing to the other side. Subtract the bags. Step one, complete. We have one bag on one side. Sweet. Now, we got to isolate that bag. We want to get rid of the other stuff so we can know what one bag equals. Take away a block, take away a block. Aha! We've got one bag equals 6 blocks. Let's reset. Let's see what we got here. If we write this algebraically, I got 3x plus 1 equals 2x plus 7. All right? 3 bags plus 1 block is the same as 2 bags and 7 blocks. Let's try to draw this out algebraically. So we took away two bags to start, or 2 unknowns to start. We're going to take away 2 unknowns on this side so we can keep it balanced. That leaves us with 1 bag plus 1 block equals the 7 blocks that remained. Now we're going to isolate that bag, get it by itself, so we take away the 1 block, but we take away it over here to keep it balanced. 1x equals 6. One bag has 6 blocks in it. All right, now back to our notes, and it's time to try going through some of these examples. Only 3 examples. I hope it's enough to get you started on your work. All right, so we're going to go here and we're going to write this neatly, really neatly as we can, showing all our work beautifully. And first things first is to remove a term containing a variable. So the variable is only on one side of the equation. All right, so we're going to be thinking of these as terms, and we're going to remove a whole term that it contains a variable, okay? So I think of this as a term, and we have that term on that side. All right, we want to go and remove one of these terms completely. Any term, you can always remove a term by addition or subtraction. All right, so this is plus 4d, so we're going to subtract 4d. That whole term we're going to cancel out with a subtraction. All right, we're going to subtract it over here as well. And now we have 8 equals 1d. All right, so it's like taking away 4 bags filled with an unknown number of objects and from both sides. And that leaves us with 1 bag filled with 8 objects. All right, so that's 8d as our final answer. All right, so our first step is to remove a variable term from one side of the equation so that we only have variables on the other side. All right, now this one, what are we going to remove first? We're going to go over here and subtract 5a. Okay, remove a variable term by addition or subtraction so that the variable is only on one side of the equation. All right, 8a minus 5a is 3a, or 8 bags, take away 3 bags, that gives a, take away 5 bags, that leaves us with 3 bags. Now we have 3 bags, and total in all those bags, there's 21 blocks. That's what that says. All right, 3 separate bags, 21 blocks. So what should be in each bag? Well, we can use division to figure that out. We're going to isolate this variable, and we get in each bag there are 7 blocks. All right, keep it going. Now this one is a little bit trickier, but this first step remains the same. Since there's variables on both sides, we want to remove one of those terms completely so that we only have a variable on one side. So I'm going to remove the 3x. I'm going to remove the 3x. Okay, now I bring down my minus 7. Why? Because 3x minus 3x equals 0. Right? That cancels out. And then 0 minus 7 would be negative 7. So that's why we bring down the negative 7 and not just regular 7. Anyway, 8 bags minus 3 bags gives us 5 bags, or 5x. Now it's just a two-step equation, which we learned in lesson 2. We learned how to solve those in lesson 2. Right? We see our two terms, and now we're going to get rid of that non-variable term, the plus 23, by subtracting 23 minus 23 on this side. That cancels out. We get 5x. Now, we see that negative 7 minus 23, that's negative 30. We just have one more step. Okay, we're going to see that that's multiplied by 5, so we divide by 5. X equals negative 6. All right, so those are all the examples that we're going to do today. You're going to have a little practice to do. We'll see how you do, and then we'll revisit this tomorrow. All right, have a great day.